Welcome back, everyone. In today's tutorial, we are diving deep into the structural reinforcement capabilities of Auto C.A. Whether you are a drafter or a structural engineer, understanding the relationship between host reinforcement and distributed elements is key to speeding up your workflow. Today, I'll walk you through a complete step-by-step beam reinforcement process, from defining the formwork and main bars to mastering the logic behind linked bars. By the end of this video, you'll see how these tools act like smart macros, making your projects not only faster to produce, but also incredibly easy to modify later on. Let's get started. So I'm gonna start the reinforcements with the bottom bars. As you can see, today we will reinforce a 3-section beam with variable openings. To be exact, this opening is 4 meters, this one's 280, and this one is 2 meters. Our cross section is gonna be 30 by 60 centimeters. This is the cross section, and this is the side view. So, as I said, we will start with the bottom bars. In the left side panel, I have already chosen the L-shaped bar style. The real cover is gonna be 3 centimeters. With that brings together the graphic cover. The view is set to both bars because I want to create both the inside bar and the outside bar, so the representation and the main bar. We will see the difference later. Length is 100 centimeters by default, but when I press this button, I can specify the exact length that I need here on this side view. I specify 454 centimeters. That's gonna be our main length. Coming down a little bit, we will see 2 yellow brackets, which need to be filled to be able to create the bar. So number of bars will start with 1, and the diameter will be 14 millimeters. Now that we filled these 2 brackets, we can create our bar. Click on the button, and we can see the preview of our inside bar, but it's not exactly what we wanted. So let's use these 2 buttons, which are mirror buttons. I can mirror this hook to the other side, and with this button I can move the reference side, other one, and with the green marks I can choose which point to be the reference point, middle one or any other points. So now I'm gonna choose this one, so this way I'll be able to pinpoint the exact location. And now comes the outside one. So this is the inside bar. It's strictly for representation only, and this is the outside bar, which is the main bar, which will be distributed elsewhere, but we will talk about it later. Let's increase the scale. And now for the other end of the beam, we will choose the mirror element button. I'm gonna select both the inside and the outside bar, press enter or space, select a reference point for the mirror plane, and the program asks me if I want to delete the source element. I don't want to, so press no, and our bar gets duplicated and mirrored at the same time. So we will need to modify its location a little bit because my reference point wasn't exactly the correct one, but some modifications. We have the inside bar at the other end of the beam. Let's stretch it so that it reaches to this point. Keep in mind that if I stretch only the inside bar with 3 centimeters, the outside bar gets modified as well because they are linked together. Okay, and for the middle bar, I'm gonna choose the simple straight bar. The other parameters remain the same. The outside bar comes here. And now that we created the middle bottom bar, we just need to stretch it a little all the way here. So there's an overlap with the other one. And that's it. We have the bottom row of bars. And now let's continue with the top bars. I'll create new definition. For that, I'm gonna use another two-sided bar. The hook, both bars 3 centimeters of cover. The number and the diameter parameters remain. I'm gonna select an insertion point and create bar. Okay, I'm gonna put both bars, the inside and the outside, next to the drawing, and let's stretch it. I'm gonna stretch this inside bar all the way to the other end. I'm gonna give it another side to this end, but for that I need to use outside bar. I'm gonna give it 50 centimeter hook, just as on the other side. And then now, to demonstrate this feature, I'm gonna break this bar, pretending that it is too long to work with. So select the bar, select the cutting point, but first choose the overlap option to enter an overlapping distance. In our case, it's 72 centimeters. And now click on the cutting point. As you can see, we have 2 different bars now. So we've just cut not only the inside, but the outside bar as well. Okay, let's continue with the cross section. For this one, I recommend to change the general scale to 1:20. If you are working in direct scale, the detail button allows you to change the scaling mode. Pressing the model button changes the geometry size, while the layout button scales the text. A small tooltip appears with information when hovering over these buttons, so it helps to choose the correct mode. For more details, see our specific tips and tricks video in this topic. So here we have the cross section. Don't forget that we are in 1:20 scale. Let's define our stirrup. For that, I'm gonna use simple stirrup option from the presets. For the sides, I'm gonna use this button again to measure the precise distances for both sides. And now we know that we need a 24 by 54 centimeter stirrup. The number of the stirrups for starters is gonna be 1, and the diameter is gonna be 8 this time. Let's check that we have both bars enabled. Yes, we have. And let's create it. We have these points as the insertion by default. But of course, you can change it to any point. This is our inside bar, and this is our outside bar or stirrup. Okay, to finish it up, we will put call out on the inside bar. Let's select the type on a bar, on an inside bar, and create call out. Now we know that this sidebar belongs to this bar marked with the 12. And now we pause for a moment. It is visible that there is only one piece of each bar. So we have only one everywhere. That is because no distribution has been applied yet. I emphasize that Auto C.A works most efficiently when the program derives quantities from the distribution rather than manual entry. So What's the program logic? This is the most complex part of the program, which is actually quite simple. You must link the stirrups to the beam distribution and the longitudinal bars to the section bars. This is how the program calculates precise quantities. And again, I want to emphasize that these elements function as macros. So they are freely modifiable and reusable anytime. To continue, we're going to create the 3-zone stirrup distributions. But before that, I'm going to define those 3 zones inside one single segment of the beam. So we have 400 centimeters, one segment. So we will need for one zone 100 centimeters. The middle zone is 200. And the last one is 100 again. That's it. These are our 3 zones. I will leave 2 markers here and I give them line type. And now let's start creating the distribution itself. This is the most crucial part of the distribution generation. We need to link to an outside bar. So we need to select our stirrup for that to be able to count all these distributed inside bars. Okay, so let me demonstrate. I'm gonna select the distance option down here, and then I'm gonna give the first spacing, which is gonna be 10. The zone itself has a distance of 100 centimeters. Another zone with a 15 centimeter spacing. The zone itself is 200, and the last zone is 10. Again, 100 total distance. So this is our scheme for the distribution. We will need the generate line. I'm going to force the extremes. So on both ends, we will have a bar. This will rearrange a little bit spacings, but it will be close to these ones, which we defined. Everything else is okay. So let's create our bar series. Click on the button, specify the insertion point, and select the orientation horizontally, and after that vertically. So here we have it, not in the correct position, but that's easily resolvable. Just simply select the generator line, move it up by 2 centimeters. We need to increase the outside stirrups height by 2 centimeters. Let's arrange the place of the inside bar. What I did was I increased our stirrup size to be able to fit the longitudinal bars into them. One more thing to change visually is to select the real view. That one I forget when we defined the distribution. So this is our first stirrup distribution, which is linked directly to the outside bar. If you noticed, we have 35 bars now, not only just one. If we update this callout with the total bars information, we will get the 35 number also, just like on the outside bar. So what it means is that this outside bar is connected with this inside bar and also with this distribution. You can check if you worked correctly with a simple stretch the outside bar. Stretch it. The inside bar has changed as well as the distribution. So this means that the links are functioning correctly. Also, alternatively, if you want to check connections, you can enter into the modification panel of the outside stirrup and click on this enable/disable the zoom position of the bar option. And now we see that from this distribution comes the 35 bar number. The callout is also linked to this bar, and the inside bar is linked as well. So this is the correct way to use the program logic to count bars. Yes, there's the possibility to insert bar number by hand, but it's always easier to let the program do the hard work. And most of the time, it's more precise also. So we can continue completing this beam reinforcement. First, I'm gonna create a callout for this distribution. Let's modify it so that we have position box, number from series, diameter, and distance. Okay, and now we see the information referring to each zone independently. Now we'll use the copy elements option, copy elements command, to make duplicate of this distribution by selecting the generator line, choosing a reference point, and putting the new distribution to its place. Click once and you have a new distribution. You can use the stretch command to put it in its correct place. Let's bring it to this point. We have the distribution in place. Fortunately, I did a mistake and I stretched the bar also. Correct it rapidly. Another distribution. We can stretch the individual zones as well if we want to. So let's make it shorter. So now my zone 1 is only 80 centimeters. Let's do the same with the third zone. This is okay. And now finish with a third distribution, also with a copy. But this time I'm gonna modify the distribution. I'm gonna select 2 of the 3 zones and delete them. It's okay. I've deleted 2 zones. I'm gonna tell the remaining zone to be this big, exactly 2 meters long. So we only have 1 zone for this beam segment. And modify. And let's check the stirrup, which has now 81 bars connected to it from all these distributions. So this is going good so far. We are counting bars automatically, which is awesome. We don't have to do it manually. We don't have to keep in mind how many bars do we have in the distribution. All these hard things put onto the software. Let's do the same with the longitudinal bars. Now the thing is, we have multiple options to make these longitudinal bars represented in the cross section. I'm gonna show you all these options. First, let's create characteristic sections. What does it mean? Well, we're gonna create cross sections in multiple places, like here, and also here. I'm gonna give these section lines another color. So it means that we will need multiple inside stirrups as well. If we want to copy this whole structure to have multiple cross sections, we will tumble into a new problem. So I'm gonna create 2 more cross sections. But now our new outside stirrups have only 1 bar connected to it. So they are counting only themselves. And this is a problem because if we want to create new bar schedule, these 2 stirrups are gonna be listed only 1 bar connected to them. So it makes confusion into builders' heads. So we have options to solve this problem. First option is to connect the individual distributions to the respective outside bars. So when I click on the 3 dotted button next to the bar mark, I can select a new bar to make a new link between these two and modify. And we will see that 25 bars got subtracted from the number of the first distribution and then got added to the second one. And we can do the same with the last one. Press on this button, select the new outside bar. So this time we will have 3 different outside stirrups with 3 linked distributions. So each one has its own distribution. This one has the middle one, and the last one has the last distribution. So this is a solution, but what I like to do is the following. I'm gonna undo all these steps. When it comes to multiple cross sections for a beam, I like to do this. I copy only the formwork in the inside bar, so we still have only one outside stirrup. So our bar schedule will be less long, will be a lot shorter, but still we will have all these inside bars connected to the main bar, the outside stirrup. The only thing is to disable the total bar from the callout this time, because it might confuse others if we have 81 bars on each position. So yeah, in my opinion, this is the right way to do multiple cross sections. I'm gonna give a number. The 1 is 2. This is the third one. Okay, now comes the next part, which is distributing the longitudinal bars into the cross sections. This is basically the same thing as we did the stirrup distributions. Let's select the bar sections, and we must use the aligned type, because this is the easiest way to represent these bars into the cross sections. So again, we need to link to a outside bar. This is the most important step. And let's start with the bottom one in the first position. So we selected number 7 bar, and their bar number will be 4, for example, 4 extremes, and create bar section. Now we will need to choose 2 reference points, and between those reference points we will have these 4 bars. Now let's modify them, because this is not the way I like to see these bars. So we need generator line, real diameter, and full bars. But what if I want to copy it and change its dimensions? Well, as I said, these are macros which you can reuse and edit. So let's try this. I'm gonna copy everything that's belonging to this one. Now we have another concrete beam with the same dimensions. I'm gonna rename these sections. So let's say that we want a 25 by 30 centimeter beam. And how do we do that? Well, we can use the stretch function to stretch the vertical dimension. For that, I choose everything with the lasso, and as you saw, I positioned my lasso to cut through the middle of every single element, the side view as well as the cross sections. So when you select this way, you can press space and make it shorter, make everything shorter. So previously we had 60, now we want 30. So we need to displace it by 30 centimeters. We wait a few seconds. This says that the current shape is not allowed, but you can ignore this error. The stretch will still function as intended. Let's bring these callouts closer to the distribution. Let's fix the position of these inside bars. Okay, sometimes you need to fix up some things, some collisions when you do similar stretch, but that's nothing too hard to do. So now we have a 30 by 30 centimeter beam, but we wanted a 25 by 30, so we need to do another stretch horizontally. I'm gonna cut through the middle of this cross section with the lasso, and I'm gonna make it smaller by 5 cm. You can see the outside stirrup changed as well as the other inside stirrups, but the formwork, of course, did not change, so we need to stretch it, and this is it. The not countable bar section series has changed, but the position remained the initial one, so we need to reposition this as well. But that's it. Now we have 3 cross sections of our new 25 by 30 beam. We can create another bar schedule table. We also have beam 1 in the bar schedule because we did not reassign element type. So I'm gonna do that. Beam 2. Now we have these 2 tables, different values. If we want to, we can also do a big table containing both our beams. And in total, we have a little more than 300 kilograms. So to recap, I'm gonna explain the logic behind copying Auto C.A elements, linked elements specifically. The key is that the primary element is the outside bar, always the outside bar. Be it the longitudinal bar or stirrup, they are both outside bar. The inside bar, the green ones, are only for display purposes. However, stirrup distributions and section bar distributions are internal bars that increment the quantity of the outside bars if they are linked. Therefore, if you only copy the outside bar, you get a brand new bar that counts as one piece. If you copy only the internal bars, you will get new inside bar, which is linked to the original outside bar, you can see. So that's how we created the other cross sections. If you copy only the bar series distributions, the quantity automatically updates at the outside bar. And if you copy both simultaneously, you will get a new outside bar with the same quantity as the original one, thanks to the distribution. It is now a new link between this new distribution, new outside bar. So means that the connections are not lost during copying. So you should always keep it in mind. And as you can see, when deleting the outside bar, the linked elements, all the inside bars and the distributions get deleted as well. And let me show you one more thing. If we copy this whole beam, we can optimize the cross sections in another way. And what I mean by that is I will need to delete the other 2 sections. This deletes the distributions, which mean that we will only get one piece of all these 3 bars. And what I want to show you is that you can assign the same bar section distribution to multiple outside bars. So if you don't want to create physically 3 different cross sections, but still you want to distribute all these bars to avoid inputting manually the quantity, then you can do this. You can select the add position in the bar section series modification panel, and you can select the 3-dotted button and click on all these bottom bars. As you can see, now all 3 bars have 4 pieces as the quantity. And if we come back to the callout gets a new look because now it includes the 20 and 21 bar marks. So we know that this single 4-bar section distribution is linked to these 3 outside bars. And we can do the same with the upper bars as well. So at position, click on this button, select another bar to link to the same distribution. And now we have a callout that's including these 2 bars. Another thing is if you want to add some 3 bars into these outside zones of the distributions, you can do this thing by copying both the inside and outside bars on the upper section. I'm gonna copy these 2 a little bit lower. I want this one to reach only to this point here. So I'm gonna stretch it and I'm gonna give it another hook on the other end. Okay, the inside bar follows the same shape. I'm gonna put it up here. And now I just need to copy this shape to the other positions as well, like here and also here. We need some stretches all the way to here, and this one needs to be stretched to this point. So these are the auxiliary rebars that help these upper bars. Okay, and now we want to show them in the cross sections. So we need to decrease the number of the longer bars, then copy this cross section series. I'm gonna change the position of the bar sections over here, bring it up, bring this callout lower, this one as well. We need to space for all 3 marks because we have 3 new bars, and let's assign those new bars to the new bar section series. So we will have this one at position, this one too, and this one as well. And the modification, and we have 2 bars in the middle, 2 in the exterior. These are the longer ones, 28 and 29, and the middle ones are the 31, 32, and 33. 31, 32, 33. Okay, so that's how we do this. It's not that hard. You just need to pay attention to the links, to which bar is linked to which distribution. And finally, the last tip for today is grouping. I'm gonna assume that we have multiple beams with the same, exactly the same dimensions. So I have 3 beams with the same dimensions. If I create bar schedule, I will see lots of bars with the same dimensions and the total weight. But if I don't want to see so many bars in the list, we can do grouping in 2 different ways. First one is to type group positions into the command bar, press enter, and click on the select, or simply type S command line. Select these 3 beams, press space, check in the use lowest value automatically option, click OK. And this way we get 3 different beams with the same bar numbers, and if we update the bar schedule itself, we will only see those numbers with the same total weight. And this way we get a smaller bar list. And there's another way to do the same thing, which is maybe the easiest way, is to select another beam of which you have multiple ones, and enter into the modification panel first for the longitudinal bar, and here in the group numbers just type in the number of how many beams you have of the same dimension. So for example, I type in 3. Now we will have modification in the labels of the bars. We have 3x, so this means that we have 3 of them, and we can do the same to the stirrup also, the number of groups here, and modification. And let's check the bar schedule. We will see that we have the same total weight as on the other example. Oh, and don't forget that if you have another formwork, you have some other dimensions, you can also stretch the whole assembly with the formwork and the distributions and the inside bars as well. So you can freely reuse and edit all these Auto C.A entities because they allow it. They allow the free stretching and moving, as long as you don't ask the software to do something very radical. See, I select everything to be stretched and the software follows my commands. So the work with Auto C.A is almost a game, just an exciting distraction. So to summarize the main logic behind the bar linking, I'm gonna create a little graph which looks something like this. I copied an outside bar and an outside stirrup. These are all the things that we attach to. We always link stuff to the outside bars. These are always outside bars. Okay, so link goes to these. And if I want to show the other side of the equation, these are the inside bar. These goes as onLINKed. So we always link these stuff to the outside ones. So the blue things, the outside bars, are the ones to which we attach elements, and the green ones, the inside bars, are the ones we attach to the outside bars. And if we want to create callouts on them, we always use the onLINKed function. That's why I wrote here the onLINKed phrase. Okay, so this is the difference. Outside, and this is inside. Okay, so keep in mind this graph. It might help you. If you want to create these callouts, these will only work correctly if this relationship exists between the entities. So yes, this brings us to the end of this lengthy video. If something seems too complicated during your workflow, you are likely not using the most efficient method. Feel free to contact us and we will be happy to show you the correct way. And that wraps up our deep dive into beam reinforcement with Auto C.A. We've covered everything from basic bar definitions and manual distribution to the essential bar linking workflows that keep our quantities accurate and your project organized. Remember, the goal of these tools is to simplify your work. If you ever feel like a process is becoming too complicated, don't hesitate to reach out to us. We're here to help you find the most efficient way to get the job done. If you found this tutorial helpful, don't forget to like and subscribe for more technical insights. Thanks for watching and happy drafting!